Welcome to the new episode of Green Gardens. I am Aishu Bharadwaj, Assistant Editor, Trade Promotion Council of India, and today we have with us Mr. Pushkar Deo, founder of Hythane Labs. Welcome to our series, sir.
Thank you, Aishu, for calling me on this series. It's a really pleasure to talk with you.
Same here, sir. And for our audience, I just want to tell you all that the guy in front of me has over 31 years of experience and is, promoting the green energy sector in a beautiful way. Sir, without wasting further time, I would just like to ask my first question. What inspired you to establish Hythane Labs? And what would be your future goals with Hythane?
Yeah, first of all, thanks, Aishu, and welcome all your viewers. We need to understand what Hythane is.
Right.
Hythane is a combination of hydrogen and methane.
Okay.
So today's industry is looking towards some of the solutions in green hydrogen as well as solutions on methane. How effectively and safely we can handle methane. What are the different ways where conventional methane treatment can be easily replaced with something which will help decarbonizing, which will reduce greenhouse gas emission. And to tell you, even methane is more potent than carbon dioxide.
Right.
It's more dangerous. So capturing methane, utilizing its source, effectively for generating very clean kind of fuel, which is the future fuel, is a need of time.
Right.
So this is name of company Hythane, because we are dealing with hydrogen, green hydrogen, turquoise hydrogen, and even super green hydrogen.
Okay.
Plus methane, various ways of handling methane, blending methane so that we can effectively equivalent reduce carbon dioxide emission wherever methane is used. So that is how it's a Hythane. What is in the lab? Lab means laboratory. Laboratory is something where we carry out research.
Right.
And this research is mainly into identifying new technologies, developing technologies for generation of clean fuel.
Right.
At present, if someone asks about clean fuel, then what comes in mind is hydrogen, because hydrogen is, yeah, of course. So even for a technology, we are investing in technology development where we can supplement with economical, effective and high efficiency hydrogen generators, using different methods. We would like remove one mental block. If I ask you to close your eye and think about green hydrogen, then what comes visualization is electrolyzer.
Right.
But is electrolyzer the only way to generate hydrogen? Is it the only way to generate green hydrogen? Is it going to be, a common solution for the globe?
Right.
When we are talking about fuel, the solution cannot be common for the globe. It should be location-centric. So that is the reason that laboratory is performing research to develop technologies where effectively hydrogen can be generated through different ways, different feedstocks.
Right.
And now I was working in MNC before this, before starting my own company, and after working, at a length, I thought that it would be prudent to start a company which will be dedicating itself for the green environment, clean environment.
Right.
If we are focused, then your objective is one, and all your team members or your colleagues or your staff, is moving towards a common goal. Now, if common goal is a problem of the globe, then nothing better than that working towards that common goal, net zero.
Exactly.
We are going to have our definite role in coming future with developing technologies, with developing engineering, with providing engineering solutions to other MNCs, EPC companies, which intend to go for green hydrogen. So it is not only that we are going to promote our own technology, but we are doing engineering for many our partners to support them in developing concepts, to develop process engineering. We are giving solutions, optimizing it, so that optimized way green hydrogen can be produced in an effective way. It's a requirement of that. Was the main motivation.
Right. And I think your initiative is going to help a lot of entrepreneurs, a lot of businesses who are coming into the sector, and I wish you all the best, sir, for the same. And with this, I want to move on to my next question. As you said that Hythane Labs specializes in providing engineering and designing support for green hydrogen as well as green ammonia projects. So could you share some examples of successful projects in these areas, also highlighting the impact of your engineering solutions on sustainability?
Yeah, definitely. In fact, we are a very young company.
Right.
It's 1.5 years old company.
Right.
But we have worked on concept development for over almost 15 to 20 number of clients in a very short time. We are successful enough, and also we are successful enough to get associated with very good
factors, I guess,
science academias. Yesterday I was in Mumbai University, and their physics department wants to have MOU with my company for providing some sort of assistance in their research work which presently they are carrying out, for facilitating their PhD students, doctorate students, and whatever engineering support, whatever technical support is required for them to take one step ahead going towards finalization of a concept. That is how they are looking towards us, and we are successful enough. So while I say that we have already worked on more than 15 number of projects, so these numbers of projects are variety kind of thing. Okay, majority of the projects were electrolyzer projects, because that this is the only thing Janata is knowing about.
Current trend, right?
and everyone is thinking that okay, fine. If we have to go for green hydrogen, that means we have to split water into hydrogen and oxygen. So when we are providing services to the client, we have to provide services based on the design basis that has been generated by ultimate.
Right.
If ultimate client wants to have electrolyzer for the generation of hydrogen, then we have to have. But what is the difference? What is the difference between our company and other companies? You have to create that very thin line which creates a difference.
Right.
A difference is that we are successfully able to do mathematical modeling of electrolyzer.
Okay.
That means alkaline electrolyzer. That means we can predict. We can predict what is going to be heat generation, what is going to be efficiency of that electrolyzer stack mathematically. So the data sheet prepared by us would be more robust.
Right.
It won't be blank and kept everything to be filled by vendor. We are going to we will be filling all the data based on the simulation model, mathematical model that has been developed by us, and then we are going to ask vendors to confirm it. So the more data you are filling in the data sheet, that means you are not giving, you are not allowing vendor to impose his or her own model on you.
Right.
because you sure what you want. And it will only and only come if you are putting efforts upfront. So
Right.
already we have invested sufficient time for developing such kind of things, and we are equipped with all kinds of the data with us, with information, and that is how we can tell vendor that, look, whatever you are putting is not meeting to our requirement. We would
Right.
like you to optimize here. And that is how we can seriously target on their materials. We can seriously target on their cost. We can seriously target on the offer that they have given. Hmm? So
Right.
this is a very thin line. Once you, I mean, those who are into process industry, they will immediately understand that a completely filled data sheet with all the numbers, all the fields are filled with data sheet, and then you are asking vendor to confirm your data.
Okay.
Rather than keeping everything open to the vendor and then asking, falling in a trap of vendor, that vendor will say, this is my model, this is excellent, and uh, 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 that I mean, very tight kind of, close kind of offer vendor then is compelled to provide you.
Right.
This is one positive side. Second thing is, because I already have worked in hydrogen environment for more than decade. So that gives me added advantage of knowing hydrogen, number one. Secondly, I know the characteristics, material that are required, and I know the even safety of it.
Right.
Because I have worked in that environment for more than a decade. Almost 15 years I have worked in hydrogen environment. So this gives added advantage. When I used to work in company prior to MNC, I was in heavy water plant, which is in the campus of Rashtriya Chemicals and Fertilizers. That
Okay.
was my first employer. And Rashtriya Chemicals and Fertilizers is a fertilizer company which is having ammonia plant, urea plant, and also there is a plant of heavy water. Heavy water is nothing but deuterium oxide, where deuterium is separated from hydrogen. So it's a isotopic separation of deuterium from hydrogen. So I was not new to hydrogen. I was
Right.
I was knowing that thing, because we have handled these systems at very high pressure, 220
Right.
bar more than. So when you know certain design aspects required for hydrogen, when you have worked in consultancy, process engineering design, then naturally you become a candidate for starting a company which is of requirement of today, and it is of your interest.
Right.
Now, when it comes to optimization, the optimization only and only comes when you are exposed to engineering.
Right.
If you ask someone who is new to carry out optimization, he or she will not be able to do it, because not because of the knowledge, not because of the education, because of experience. That is
Right.
the reason that when you have sufficient experience at back, then you are co-creating everything that you have seen, that you have done previously, and
Right.
trying to implement in your design so that the project cost will come down, and eventually it will benefit to both, to your immediate client and ultimate client.
Right.
Because finally, this CPI, chemical process industry, its mentality, its psyche is to generate profits.
Right.
Okay. It's very ruthless industry. Chemical process industry is not unlike other industry. It's not charitable. It's
Right.
only thinks towards generating profits. So a payback period of your project, if it is narrowed down, then your profits are going to increase. Industrialists would try to expand further. So in
Right.
that line, if you are working using your experience, using your knowledge, motivating your team to work in that direction, so that it will not be only a guideline based engineering, but it would be more experience based engineering. and something which is must you have to provide, something which is good to have you have to avoid.
Right.
And we have done that thing for our clients. Our clients are coming to us because we can deliver quickly. We will have that data with. Since we have developed those process engineering documents for others, that means it is only customization for new project, and that is how we can deliver quickly.
Right.
So our customers are repeat customers. Customers don't want us to do work for the others, their competitors.
Yeah.
So we make them happy, they make us happy.
Right.
And particularly ammonia, green ammonia, there are many folds to it, Aisha.
Right.
It is not only that green ammonia is needed, but green ammonia can be useful in many ways.
Right.
Without urea, our agriculture industry will not flourish.
Right.
We have to understand one thing, that we are 1.4 billion, people living in this, in this country. Now, it's a fact. Organic fertilizers may not provide you that kind of yield.
Right.
So, for making urea, you require ammonia, you require carbon dioxide. Now, you can get ammonia through green route, but at the same time, to have urea, you have to have carbon dioxide.
Right.
So, present, fertilizer industry, which is mainly run on SMR, steam methane reforming, it will keep on running. It will keep on running because you require fertilizer. Even so many fertilizer plants are in India. So many fertilizer giants are operating in India. Still, there is import of urea.
Right.
And we are not stopping. I mean, it's 1.4. We are not reducing to 1.39. Maybe we will be 1.41.
Right.
So to fulfill the hunger, you have to produce that kind of crops, that kind of grains, that kind of food. And everything is linked here. So if an economy is surrounded or rounding towards agriculture and people centric, then your solutions shall be suitable enough to meet the immediate requirement of people. You can meet the requirement of industry, but it is very difficult to meet the requirements of people, because finally all industries are set up to provide services to the people, provide products to the people.
Right.
Okay. So green ammonia is one thing which is going to be a future, because ammonia is again a hydrogen storage, like methane, like hydrogen. Even ammonia can store hydrogen. Okay, ammonia stores hydrogen. So if ammonia is very near to propane in terms of its properties like vapor pressure, its properties like it is also having very high octane number. So it can be used as a fuel.
Right.
It will not generate greenhouse gas carbon dioxide, but surely it will generate NOx, which is also equally not good. NOx is generation of NOx. But when technology is developing, even this ammonia fuel engines are going to develop in terms of reducing NOx levels, and ammonia also can be used as a fuel. Else, there are many other uses of ammonia. So wherever a small user other than fertilizer we are thinking of, then and affordable fertilizer cost, okay, then this ammonia also can be generated using green technology, and a green industry, particularly downstream of ammonia, can get flourished. That is our view.
Very well, sir. That was quite a descriptive answer, and I am sure that our audience is going to love this session. But with this, I want to ask my next question. Steam methane reforming is a key process in hydrogen production, right? So, what innovative approaches or technologies does Hythane Lab employ to enhance the efficiency and environment sustainability of SMR or for green hydrogen production?
SMR, SMR, using SMR cannot be, a green. SMR will always generate gray.
Okay.
See, there are a couple of limitations to SMR. SMR cannot run with a very small capacity.
Okay.
So typically, where hydrogen is produced using SMR, these are high capacity plants. Now, what is steam methane reforming? The name itself, specifies that steam and methane, they are reacting together in a reformer to give you carbon monoxide, carbon dioxide, hydrogen.
Right.
Then further, this carbon monoxide is converted to hydrogen using water shift reaction.
Okay.
Where CO, carbon monoxide is reacted with steam or water, H2O, to donate hydrogen from water and liberate carbon dioxide.
Okay.
Take a case that you are using methane from a source which is a fossil fuel source.
Okay.
That means you are generating carbon dioxide.
You're right.
For circular economy, when we say that at least let us think of carbon neutral SMR. That means methane is replaced with a biomethane.
Right.
If your methane is replaced with the biomethane, that means you are keeping a CO2 level constant. Even though CO2 is liberated out, CO2 is vented out, but still that CO2 you are not increasing in atmosphere. Whatever atmospheric carbon you are consuming, the same amount of carbon you are releasing. So it becomes a carbon neutral. Even that thing also you can control. Even that carbon dioxide also you can trap.
Okay.
You can trap carbon dioxide. You can transport carbon dioxide. You can use it in the fertilizer units.
Okay.
Typically, in old days, fertilizer units used to run on partial oxidation of oil, then naphtha reforming, and then gas reformer. So wherever you have higher hydrocarbons, heavy hydrocarbons, there carbon dioxide generation is going to be huge.
Right.
When in methane, that is a molecular weight is 16. So you have 12 kilograms, let's say, in the 16 kilograms of methane, you have 12 kilograms of carbon and 4 kilograms of hydrogen. That means when you are reforming it to hydrogen and carbon dioxide, or we are combusting it, that means you are going to get 44 kilograms of carbon dioxide from 12 kilograms of carbon in methane.
Right.
If this methane is ethane, still it would be absolute quantity of carbon dioxide would be high.
Right.
So where the plants which are operating on methane, first naphtha as a feedstock, the first thing is if they can shift it on methane, then their carbon dioxide will reduce, their ammonia production will increase. In a ammonia plant SMR I'm talking about, their hydrogen production will increase if they are running for the hydrogen units. Okay. But once this CO2 is formed, then this CO2 you can capture, so that though you are not polluting additionally using biogas or bio CNG for SMR, at least you are reducing carbon dioxide equivalent from the atmosphere.
Right.
We have some association, marketing association, other association with a company. It's innovation company. Its name is Pagnism.
Okay.
Pagnism India Private Limited. And Pagnism, they have developed a technology. It's called as thermal decomposition of methane.
Okay.
Which is direct disruptive technology for essence. Okay. Where using this technology, you are breaking methane into hydrogen and carbon. That means whatever carbon is getting converted to CO or CO2, you are bringing back to solid form. And carbon black is in demand. It's useful everywhere. Whatever black you see, basic ingredient is going to be carbon black.
Right.
Even if your car tomorrow are going to run on EV or hydrogen, they cannot run without tires.
Right.
And in tire industry, carbon black is required.
Right.
Ink is required. Pigments is required. So, so this carbon black is in demand. Presently, all this carbon black is generated through hydrocarbon route.
Right.
If you are generating carbon black, then from a methane, whether it's a PNG or pressurized natural gas, which is coming from, let's say, hydrocarbon route, fossil fuel route, or it is a bio route. If it is a fossil fuel route, then what we are doing is we are making carbon negative cycle, because that carbon dioxide you are locking. You are not allowing to escape, you are locking it. If it is from bio route, then you are generating super green hydrogen. Because already you are taken carbon dioxide from the atmosphere, you have converted through bio route, it is converted to methane. That methane you are decomposing, breaking it to hydrogen and carbon, and that carbon black you are again locking. So this becomes one negative cycle, and your hydrogen will become super green. So when people are talking about green hydrogen, we are talking about even generation of super green hydrogen.
Right.
Okay. So conventional hydrogen generation plant presently, those are run on feedstock as a methane, are using methane as a fuel in their furnaces. So whatever carbon dioxide is escaping in the form of flue gas, even that can be captured using carbon capture methods.
Okay.
And you can, support in decarbonization effectively. So at least my wish that most of the fertilizer units running in India are owned by government. Either it is an enterprise or public sector companies.
Right.
When government has given mandate for the decarbonization, they have given targets. That means all the agencies, all the industry must look towards it, irrespective of what kind of loss in their profit would be for some years.
Right.
And that's my sincere request to all fertilizer industries to immediately think of going for, carbon capture in whatever technology supports to their wallet. But they must think of, because whatever additional carbon dioxide they will be generating from flue gas, anyways, it will result into urea finally, which is going to farm, and it will help agriculture and reduce equivalent import of urea.
Right. Thank you again for a descriptive answer. And moving on to my next question. What are some of the main challenges and opportunities associated with the widespread adoption of green hydrogen and green ammonia, both in terms of technological advancement and integration into existing energy infrastructures?
I'll tell you. Number one thing is, while opening my statement in this discussion, what I said that the solution cannot be common for the globe. Generation of hydrogen through only electrolyzer is not a solution. We have to have a solution which is location-centric.
Right.
Now, I'm giving you one example. We have areas in India where water shortage is like anything. It's such a commodity where people are really starving for getting natural water.
Right.
Now, if you go to cities like Chennai, where there is a water shortage and there are desalination units for supplying water, potable water, water or usable water through desalination of seawater. And if you go there and ask them, say them, you give me water, I'll give you hydrogen. Is it a solution for Persian? Is it going to be a solution for Gulf countries where already their energy is invested in desalination and producing water? You go to Qatar and if you tell them, you give me water, I'll give you hydrogen, they'll say, I'm having sufficient gas. If you can give me water, if you can give me hydrogen, and if you can give me energy, it's more attractive to me.
Right.
So electrolysis is a technology, is very old technology. It is not something new that has been invented. It is very old technology. Nowadays, scientists and industries are investing their time and money to improve efficiency of that.
Right.
Just like 50 years back, a car used to give fuel efficiency of 4 kilometers per liter. But today we have cars running on petrol. They can give efficiency of 24 kilograms per liter.
Right.
Okay. So in the same way, efficiency improvement projects have been taken up by many.
Right.
That cannot be a solution which will be common. So there has to be location-centric solutions. And what could be the location-centric solution is one that is a CMD, which is catalytic methane decomposition. Catalytically, if you are able to decompose methane and generate hydrogen and carbon black, that means in an industry, you are also getting carbon black as a byproduct. You are selling it in a high demand industry. You are also generating hydrogen. You can run fuel cells on hydrogen, generating power and water.
Right.
So gas-rich countries, if you go to them and ask them for gas, which is a dirt cheap, your hydrogen cost is going to be very, very less.
Right.
At the same time, if Qatar or Gulf countries are asking, hydrogen from India through electrolysis, water electrolysis. So 1 kilogram of hydrogen, when it is fed to fuel cell, generates around 14 kilowatts of power, average 14 kilowatts of power, and 18 kilograms of water. That means along with 1 kilogram of hydrogen, you are not only sending energy, but you are sending water also.
Right.
Infrastructure, land mass, biomass, everything would be used from Indian soil. Because India is blessed with that. India is having huge land mass. India is having huge biomass.
Right.
India is the only country where solar radiations are more stable.
Right.
Wind velocities are more stable. So for generating green energy, India becomes a natural, partner for the West, for the developed countries.
Right.
At the same time, when one of the part of country is using desalination methods for generating water for daily uses, and other part of the country is utilizing water for generating energy, doesn't suit, isn't it?
Right.
So we have to make effective use of our biomass, effective use of land mass, and optimized way of generating hydrogen using electrolysis, and use the alternate methods for generation of hydrogen, which can be cheaper in cost, competitive in the market, and it can be very well easily adapted by local people.
Right. Right, sir.
I see challenge, that industries typically most of the industries follow others. We definitely have a habit towards following successful person or successful industry. So someone is coming up with a technology for electrolysis of water. All we are running towards it, you know.
Right.
But we seriously need to think what are our resources which can generate hydrogen, which can generate fuel.
Right.
I'll tell you, we are number one in number one country on the globe with number of cows. We have goshalas everywhere.
Right.
Goshala generates biogas.
Right.
Biogas is nothing but around 50% of methane.
Right.
Separate methane converted to hydrogen and carbon monoxide. Even goshala can export energy.
Right.
Okay.
A wonderful, wonderful solution again. Right.
Municipal waste, you can convert it to biogas. Convert that biogas to hydrogen using CMD. Even municipal waste can provide you hydrogen.
Right.
Objective is cleaning environment using hydrogen. But at the same time, our objective should be that we have to develop and adapt a technology which is, which will generate sufficient environment, as well as local technology, as well as making use of resources available locally.
Right.
And no one can deny that if energy is governed by farmers, then that would be a golden era.
Right.
We have a lot of biomass, Only thing is we have to tap it and convert it, make hydrogen out of it.
Right.
And it's possible.
Right.
We are also working on certain solutions to make use of this biogas, splitting biogas, not only thermally. Ultimately, it is going to be thermal, but very effectively using.
Right.
Yeah. This is also not a new technology. It is age-old technology.
Right.
But we are adapting it. So, different ways of generating thermal heat or heat. Either you can use microwaves for that. You use plasma for that.
Right.
And effectiveness and the capacity of that unit, if you are able to upgrade, then nothing is better than. So
right.
Presently, we are also engaged in research for plasma.
That's great, sir. There are n numbers of solution Hythane is offering right now, and it is great to know that. So with this only, I would ask my last question, sir.
Yeah, please.
To what extent do you believe that government collaboration and partnerships are essential for accelerating the deployment of green ammonia technology in India? And what specific measures or initiative do you think would further promote its adoption and integration into the national energy landscape?
First thing is government is very serious about
Right.
decarbonization.
Right.
Government has, I think, couple of months back, government has released policy also.
Right.
Policy. Maharashtra government, where I stay, has already released a state policy for green hydrogen.
Okay.
So, on policy front, governments are active.
Right.
What is going to accelerate?
Right.
The acceleration will be, keeping the technology open for generation of hydrogen. A tender should ask for capacity of hydrogen and not the way it should get generated. Only thing is, you can mention that green hydrogen shall be generated without carbon dioxide emission. That's the point.
Maintaining the CO2 net zero goal. Right.
Net zero. My objective of generating hydrogen is not something because I love hydrogen, because also whatever mess we have created, we need to clean it.
Right.
So if government tender is asking for electrolysis, then you are bound to go for electrolysis, because that tender asks for particular technology. If tender is open, you give us concept, show us your working prototype. We are there to support you and take your technology to global level. That is acceleration.
Right.
I'm happy to tell you that our company has been selected under Cornell Maha 60 Accelerator Program.
Okay.
So Maharashtra Government Department of Industry and Cornell Ivy League University Cornell. It's a 1-year intensive program where 60 such startup businesses are selected.
Right.
For under their accelerator program. So government from their side, it's not only to promote certain products, certain industry, but they are also investing their money and time for developing entrepreneurs.
Right.
If I'm having a confidence that whatever I am going to do seriously, sincerely, there is some agency, whether it's a government or some a strong big industry behind me, where I will be supported financially, where I'll be supported administratively,
right,
academically, then a success is, though not guaranteed, but definitely probability of you being successful is very high.
Right.
It increases. So Maharashtra government has already investing on 60 such businesses like me. And the tie-up is not with any other small university. It is with the Cornell. Okay, so your window gets open. Networking becomes very easy. And when I know that there are 59 others along with me, those who are either establishing their business or want to establish their business, then automatically your network expands.
Right.
And that is how, once network expands, you know what other wants, what you want, where you can get this support. Then that itself is acceleration.
Right.
It is not only for the particular product.
Yeah.
Particularly for decarbonization, there is definitely requirement of government to import certain things.
Right.
As I've told you that chemical process industry is not for the charity; it is for earning profits.
Right.
So industrialists are going to think twice before investing their money.
Right.
But when it will come from government that you have to, this is a mandate given to you. Right. Something like BS4, BS6.
Right.
Gasoline purity levels, something like that, which will tell you that, okay, fine, if you are running this industry, your feedstock shall be this. When if it is a shell, then your industry will definitely have to have implementation for that. Okay, so I mean, certain things democratically not possible, so you have to go with some sort of dictatorship, or you have to go for it because although you are giving urea to the fertilizer to the farmers, but at the same time, the people who are not directly using fertilizer, indirectly all we use fertilizer, but directly not using fertilizer, why you are exposing equivalent to them to equivalent pollution by releasing carbon dioxide. You have to identify such industries, you have to make unorganized industries to organized industries, where their environmental audit will be done. And it will not be only audit that identifying something lacuna in the industry, but you have to give solutions, you have to give subsidies.
Right.
You have to give them something like, okay, fine, you don't have money, we have money, we are going to invest in you, however you stop this.
Right.
Once this is done, all your rivers are going to get clean, or your environment slowly is going to get clean, because we have seen in COVID time, when all transportation or majority of the small scale industry batch processes were not running, that time earth calibrated itself beautifully.
Right.
So globe has got capacity to calibrate itself.
Right.
But we just cannot wait for that thing. We cannot stop everything. So we have to support entrepreneurs, small entrepreneurs, with subsidies,
right,
so that they can they can take action. And you have to impose laws on big industries, so that they will reduce their profits and go for decarbonization. What is the fun? A government enterprise is declaring profit of 35,000 crore and emitting huge amount of carbon dioxide in atmosphere.
Right.
We don't want your 35,000 crores.
Right.
You invest in reducing carbon dioxide, that would help your neighborhood. So somewhere government need to impose laws, become strict on the at least government-owned industries. That would be enough.
Rightly said, sir. And I'm sure that some or the other way your suggestion should reach the government and it should be applied, because not just the big industries, small players, upcoming players too need right policies and right investment. And with this, thank you so much, sir, for taking out time. I know young entrepreneurs like you are very busy, but this was an amazing episode, and I'm sure our viewers are going to love it. And for our audience, that's all for today's episode of Green Guardians. I would request you all to watch this episode to learn about, because how beautifully Mr. Deo has described, all the processes. It was, sir, it is, one of our first interviews where, we actually talked about, the chemical processes and how, the breakdown of methane, hydrogen, and it is, trust me, it is going to be a very informative interview when it is going to come out. Thank you so much, sir. And
I tried myself to keep, a little bit low on process engineering. Otherwise, it
I
will
understand,
be
sir.
Training session.
Right. So that's all for today's episode of Green Guardians. Keep supporting sustainability. Thank you so much.
Thank you.